Hey everybody, I wanted to make a video about using Inventor sketches as calculators. I find it pretty helpful to be able to visualize some calculations I need to do, and Inventor can be a pretty powerful calculation tool. It can figure out a lot of things just by adding constraints and letting it figure out what the dimensions need to be. So first example here is a lifting sketch. So this is just a simplified lifting diagram for this rectangle. So this rectangle is 8 by 2 feet, and the center of gravity is offset. It's off the center by a foot. And so I know I want my two slings up here to have a minimum sling angle of 60 degrees, so I've set that. And I know I want my hook to be above my center of gravity so that this thing doesn't want to kind of list one way or the other. So I've constrained it like that, and I get a resultant sling angle and sling length. So that's helpful, that's handy. It figures that out for me. A better use of it than that is to do some calculations, kind of save yourself some time without needing to mess with trigonometry, letting Inventor do it for you. So in this example, I've drawn some right angle triangles on the slings that kind of represent the sling loads and their horizontal and vertical components of that load. So the vertical line here being the vertical component and the hypotenuse being the tension in the line. And I've drawn this big line here to represent the weight, and so I've set it to be 14,250 pounds. And now I just need to figure out how much of that load is picked up by either side. So I start with the vertical component of each, and just by the moments needing to equal 0, I know that the full weight of this thing right here at 3 feet is going to be suspended by the vertical component over here at 8 feet. So I can just make that a function. So I can say the total weight is 14,225 pounds times this distance, and then divide that whole thing by the overall distance, gives me my vertical component for this sling. So to help me visualize this, what I'll do is I'll just kind of throw those weights into this diagram, but to make it more manageable, I'll just divide them all by 1,000 pounds so that their scale is a little more reasonable. I'll do that for this last one. And there we go. Now we got a representation of how much more load this sling is picking up because it's closer to the center of gravity. So that all makes sense, and that's pretty slick. And now all I need to do to figure out what the axial load in those slings are is to get an aligned dimension on this hypotenuse. And now I know that the tension in this line is 6,170 pounds. And I can do the same for this one. And yeah, that would be the number I need to design my slings around if they're going to be the same size. But just a neat way to kind of visualize what's going on, and saves you opening up a spreadsheet, and it's all updatable. So if I go back into my first sketch and I change my minimum sling angle requirement, maybe headroom's an issue, then I get my updated loads kind of instantly. So it's just nice for doing stuff like that. That's the first example. Second example is another lifting one. In this case, I have a round object. It's 1 meter in diameter, and I know I want my sling angle, let's say instead of 70, I say I want it 60 degrees from horizontal. So by making these lines tangent to that circle, so I have 2 lines and 1 arc, I can just grab the line lengths and that arc length and add them up in a straight line down here, and I can get a resultant sling length that I need to make that happen. And then if the diameter or the angle changes, oops, try 70 here instead, it'll show me what my updated sling length needs to be. So that one's pretty slick. I like using this one. The last one is kind of neat. So this rectangle has two inputs. The perimeter is the main driving one. So in this case, it's 500. And the other one is the aspect ratio. So I've set up these lines to be equal to these lines and the short lines to short lines here. Overall, it's constrained by the perimeter. And this one's just along for the ride. So it's being driven, so it's being computed by Inventor. And I'm just saying that this line over here is equal to that one. And same with this. This one's equal to this one. So the only one that's doing any calculation is this line knows that it's 3 times as long as the short lines. So if I change that to 2, the aspect ratio changes, but the perimeter stays the same. And same, if I change the perimeter, the aspect ratio stays, and it just calculates it for me. So I don't know, I thought that was pretty slick. And so I was just curious. I wanted to get a discussion going on how other people are using sketches as calculators, because there's probably slick ways to do things that I haven't even thought of. So I just thought I'd get the conversation rolling. So let me know how you use them as calculators, and thanks for watching.